This is problem number 3 on the sample test problems for test number 3. And this problem is actually taken from page 460 of our textbook. Assume the C triangle of the Koch Snowflake has sides of length 6 centimeters. Let M denote the number of sides, L the length of each side, and P the perimeter of the snowflake obtained at the indicated step of the construction. A, complete the missing entries in the table. Okay, so the first row says that M, which is the number of sides, is 3, and L, the length of each side, is 6. That was given. 3 sides because it starts with a triangle. And then the perimeter is just the product. Number of sides times the length. 3 times 6 is 18. And then it turns out that the next step, after you add a bunch of little equilateral triangles, gives you 12 sides. That's the M. And each of those sides is only 2 now. They're much shorter. And when you multiply those, you get 24. So we want to start filling this thing in without maybe drawing all the pictures again. So we just need to know a couple of facts about the Koch Snowflake. So first one is that the number of sides is 4 times the previous number of sides. So if I just multiply by 4, 4 times 12 is 48. That's how many sides are on the next generation, the second generation of the Koch Snowflake. Multiply that by 12, is that 192? Sorry, multiply it by 4. I think we get 192. And then multiply that number by 4. I think it's 764. Let's just double check that before we go too far. Okay, so we started with a 3, multiplied it by 4, we got our 12, hit enter, and it says, oh, you just want to keep multiplying by 4. That's 48, 192, and then, 768. Okay, so we'll fix that. And then it says go down to step 40. Right, clearly there must be some better way than hitting enter, like 37 more times or whatever it is on this list. So let's see if we can find a better way to get that row. Instead of thinking of just multiplying the previous number by 4, which is a recursive way of thinking and would rely on having the 39th step in order to get the 40th step, let's see if we can come up with a more explicit way to think of it. Maybe better than thinking multiply by 4 to get from 12 to 48. How about we think about going back to the first number and recognizing that this is really 3 times 4 squared. And this next one here is really 3 times 4 cubed. And you can check that, that calculation. You'll see that it's right. So this is really the pattern here. It's really 3 times a bunch of 4s. How many 4s is just the same as whatever step you're on. And so I'm actually kind of thinking of this, that if I want to get to like the nth step, then we got a formula. This is an exponential growth model. And so we'll write in English the formula for exponential growth. You take your starting number, you multiply it by the common ratio or the multiplier, and you raise that to the n power. That's our formula for exponential growth. The starting number here, the original number for m was 3 times the ratio. What do you multiply by every time you go down that column? You multiply by 4. And then you raise it to the n. So that right there is a good formula we can use to find the number in step 40. So let's fill that in. If I go 40 steps in, it's really 3 times 4 to the 40. And so I'll just put that here, 3 times 4 to the 40th power. And you can type it in, it's some astronomical number. And it is the same thing I would get if I hit the enter button enough times here, but who wants to do that? 3 times 4 to the 40th power. Okay, 3.6 times 10 to the 24th. There's a lot of sides on this thing when you get down to step 40. Okay, that's all we need to say about the side number of sides. Although I guess we could say that we've already answered this problem right here. In part B, it says for the snowflake obtained at step n of the construction, express all these guys in terms of n. So I think that we've done that. It's this formula right there. Okay, so we're done with the first column. Move on to the second column, which is the length. So the original length is 6. When you go to the next stage, it's 2. Then it turns out every time it's 1/3 of the previous number. So this guy gets multiplied by 1/3. And then this guy gets multiplied by 1/3, so that makes it 2/3. And then this guy gets multiplied by 1/3. So let's see, if I multiply 2/3 times 1/3, that's 2/9. Then multiply that guy by another 1/3, 2/27. And again, you can get decimals if you type stuff into the calculator, but I don't want to do 40 things if I want to fill in that last row. So how about we come up with something better here? The length is 1/3 of the previous length. So that's our kind of rule in English. And so if I want a formula here, ln equals, so we're doing the same kind of pattern. It's the starting length, starting number was 6 in this case, times, and now we need the ratio. What do we multiply everything by to get to the next entry for that length column? It's always times 1/3. That's your magic ratio. And then it gets raised to the n. So that formula is the answer to the part B question for finding L. But we'll go ahead and use that formula to fill in the last row of our table here. In the 40th stage, it's 6 times 1/3 to the 40th power, which is extraordinarily close to 0. The lengths of those little teeny tiny triangles are very, very small when you get 40 stages into this process. Okay, and then it says the last column here is the perimeter, and we know we're supposed to multiply in order to get perimeters. So we'll go ahead and multiply straight across. 48 times 2/3. You can check, I think that's equal to 32, and it's still centimeters. And the next one we're doing is 192 times 2/9. And so you can do fraction stuff. At some point, we're going to relent and do decimal stuff. So I'm willing to do that right here. So we do 192 times 2 divided by 9. 192 times 2/9. So we get 42 and change. Say about 42.7. Next one, 768 times 2/27. And that's about 56.9. And then we get down to our last one. So what we want to do here is multiply the enormous number in purple in the last row. 3 times 4 to the 40th. That's how many sides, and then multiply by the length of each side. 6 times 1/3, also to the 40. And I get that rather large number. So we'll copy that one down. We'll just round it up. Let's see, so what is that? 1,789,870, we'll say 2. 178,987. So it goes right in there, 178,987. And we're going to round that to a 2. Okay, double check we've got the right number. All right, I think that's good. But what are the units here? Well, the last column has been perimeter, and it's been in centimeters from the very beginning. So this is centimeters, and a million centimeters is not a very reasonable way to describe the perimeter of this object. So let's see if we can't get from centimeters to kilometers. Okay, I know that there's a certain number of centimeters in a meter, and I also know that there's a certain number of kilometers, sorry, I guess a certain number of meters in a kilometer. And the nice thing by putting the fractions this way is that when we fill in the numbers, meters will cancel, centimeters will cancel, and I'll be left with some number of kilometers, which is what I want. We just have to fill in the blanks. Okay, how many centimeters in a meter? There are 100 centimeters in 1 meter. How many meters in a kilometer? There are 1,000 meters in 1 kilometer. So this is what we need to multiply. So we have our enormous number. It's already typed in there. I'll just hit the times key. Times 1 divided by 100, or simply divide by 100, and then times another 1 divided by 1,000. And even before we hit enter, maybe you could guess what's going to happen to this decimal point. It's just going to move. Maybe you could figure out how many places it's going to move. And it turns out because of the 5 zeros that we had up above, 2 from the 100 and 3 from the 1,000, the decimal point just moves 5 places to the left. One very nice thing about doing operations in the metric system. So we get about 17.9 kilometers. So at the 40th stage of the Koch Snowflake, the perimeter is about 17.9 kilometers. Okay, and then the last thing we need to do for this one is to find a formula for P in terms of N. So it's the same basic idea. It's always equal to the starting amount times the magic ratio to the right power, to the N. We just have to fill these things in. Okay, the starting perimeter. Go all the way back up to the top right in this table. Starting perimeter is 18 times. Okay, now we need the magic ratio raised to the N. And as soon as we find this ratio, we're done. The question is, what happens to the perimeter every step of the way? Well, let's think about this thing we wrote in purple at the top. It says the number of sides is 4 times. Every time you go down a row, you got to multiply the number of sides by 4. Now let's take a look at this blue in the bottom here. It says the length is 1/3 of the previous length. Every time you go down a row, you got to take 1/3 of the previous length. So the perimeter is going to have both of those effects. It's going to have the purple, multiply by 4, and it's going to have the blue, multiply by 1/3, or just divide by 3. So putting those two things together, multiply by 4 and divide by 3. So there's your formula for the perimeter, and in fact, I'll tell you that the formula for perimeter always has that magic ratio of 4/3, because every time it's times 4 and also times 1/3.